Alright, welcome to this quick review for our final test here in Math 105. We're going to go through some of these problems, others we may do in class, and this way you'll have a good guide that you can kind of work off of. Now the questions on your actual test will be slightly different, but along the same line. So as we read through this first problem here, it says John invests $5,000 at 6% simple interest for 8 months. First word we come to is this word simple interest. When you see simple interest, you know you're dealing with one of two formulas, either I equals PRT, which will give us the interest, or amount is equal to P times 1 plus RT, which will tell us the future value. And so what we do here depends on what the problem is asking about. So in this problem, it says determine the amount of interest earned. Because we want interest, we use that formula. Now the other thing you have to be concerned with in simple interest problems particularly is the time period. Is the time period a year, or is it, something less? And in this case, it's 8 months. So when we put this into our formula, I equals P, $5,000, R is 6%, and it's for 8 months. So 8 months is 8/12 of a year. We divide by 12 because we are dealing with months and not years. And then we just compute that and we'll have the interest. Now when we do that, we get interest is equal to $200 only. Okay. Now the next example also uses the word simple interest. It says Teresa puts $3,400 in an account that pays 5.5% simple interest. If she leaves the money in the account for 20 years, how much will she have? So the difference here is we want to know the have amount. And so we're using this second simple interest problem. Again, the only time you're ever going to use these simple interest problems formulas is if it says simple interest in the problem. So here we just put in our amount, and then we work this out. $3,400 in the account, so 5.5%, so plus 0.055, and then it said 20 years. And again, now we just go and compute that. And when we compute that, it works out to $7,140. So that will grow to $7,140. Now as we come to example 3 here, it says Pariah invests $842 in an account that pays 4% compounded annually. How much does she have in the account after 10 years? Okay, so the first thing we see here is compounded. Okay. But compounded can also be used in our annuities as well as our compound interest. The key idea here is that this money is being put in once. This money is being put in once. It's a one-time deposit. When it's a one-time deposit, then we deal with our compound interest formulas, and there's two of them. The first is amount equals P times 1 plus R over N to the NT. That's one of them. The second one is the reverse of that, the present value one, is equal to amount divided by that quantity, 1 plus R over N to the NT. And so because it's once, we know we're dealing with one of those two formulas. It's a one-time deposit, we know we're dealing with one of those two. Okay. So this time we know what we're putting in. Because we know what we're putting in, that means we're going to use this formula here. and then we would go ahead and put our amount in and work that out. And so when we do that, we get 1246.37 when we round to the nearest penny. The final one on this page I won't go through very thoroughly, but as you read through here, on her 25th birthday, Aunt Belle puts $200 in an account that pays 3.5% monthly. She proceeds to forget about it. When she passes away at the ripe old age of 81, the account's turned over to her nephew, Caleb. Now this question wants to know interest. Be very careful here. We have one formula for interest, but it only works for simple interest. Okay, this is compounded, okay, and it's also a one-time thing. So what we're going to do in this problem is we're still going to use this same formula again. That will tell us the amount of money, but we again want to know interest, so once we know the amount of money, we can figure out the interest. So we would use our formula to compute the amount, which would be $14.15.82. That's what it would be in the account after the time she turns 81, which by the way would be 56 years, from age 25 to age 81. And then once we know the amount, then we can figure out the interest. So hopefully this helps you, guides you, at least gives you a way to start working about these problems and seeing what to look for. We'll do some more examples in the next video.